According to ID Tech report published in August 2020, sensor market is expected to increase to $250 billion by year 2040. Metal fatigue is a slow but dangerous process. 90% of all industrial accidents are due to metal fatigue. People have difficulty visualizing what causes fatigue. As machines work, the forces acting on different parts cause small, tiny flexing movements. No matter how strong or sturdy the parts look, forces cause small, tiny flexing of the parts. Eventually, these tiny flexing movements cause the parts to break apart. COVID-19 affected everything negatively, except the sensor market. Remote monitoring has become much more important than before. We believe we have the most important sensor for remote monitoring. Our sensor is superior to its competitors in many aspects. It consumes little or no power, it's practical to apply, it generates very little data, and it's easy to use. Now I'm going to show you how the sensor is applied with a real demonstration. This is a vertigo chair used for treating vertigo patients. This sturdy pillar actually bends a tiny amount every time it moves. It is hard to believe this until you see it. These tiny movements are measured using strain gauges, as in this case. Strain gauges show you the tiny movements, but they won't show fatigue on the part. Our fatigue sensor has tiny fingers with engineered notches to monitor the fatigue process. The sensor is applied to the critical parts of the structure and flexes with the structure. As the fingers reach their fatigue limit, they break one by one, indicating how much life is left in the structural part. The first finger is set to break at 10% fatigue life, next at 50%, 70%, 80%, and 90% of the fatigue life. So you get 5 warnings, like 5 road signs indicating how much distance is left for the ultimate end point. We installed several sensors on this chair to demonstrate how the fatigue sensor is used. This one is an integrated fatigue gauge and strain gauge together. We have a test probe and everything extended via cable to the sensor electronics. This is an RFID sensor. Sensor, electronics, and fatigue gauge, they are integrated into one package. It's totally self-contained. We have one more sensor here. Sensor and electronics integrated into one package, and it's totally self-contained with battery inside. The data coming from RFID sensors can be integrated in an app like this with a visual dashboard. Our electronics are so advanced, you can tell the sensors to send you an email or a message when they reach a certain fatigue level. This sensor has a strain gauge integrated inside. So using the strain gauge, we're actually measuring the force acting on the sensor. So what you see as the movement is actually coming from these strain gauges. Now what you see here is the fatigue life of the first sensor. What you see in the middle is the test probe. So this is the test probe that we connected to our first sensor. We use it to check, to simulate the action of the fatigue gauge. So now to show the action, I'm setting the switch to 10%. So now it's acting as if the 10% leg is broken. Now I'm setting the finger for the 50%. So 50% is broken, 70%, 80%, and 90%. So these are used for testing the sensor. And the third one is actually coming from the sensor underneath. With COVID-19, it became very important to monitor structures remotely. You can put thousands of these sensors in ships, aircraft, structures, nooks and crevices of these places where you can't normally reach. Monitor the health status of these things remotely for years to come.